All right, students, we are starting with Chapter 5, Day 3, writing linear equations in point slope form today. This is a new form of writing a equation of a line. So this is very important. It is definitely new, but we are going to bounce off of ideas from slope-intercept form. So I want you to go ahead right now, pause your video, think about the expectations for this. You need to be taking notes on your OneNote. You need to be asking questions as needed, jotting those down if you're in a flipped classroom and making sure to ask those tomorrow. You need to be pausing the video if it's going too fast or if you need to look something up, rewinding if something went too quickly and you need to hear it again. These are all expectations that I have for you. So I want you to go ahead and do your warm-up. Here is my work for the warm-up, so I want you to pause and I want you to check your answers with mine. If there's any of this that you didn't understand or you didn't get, please, please, please jot this down and ask me tomorrow so that you can get some clarification. And we are going to go ahead and get started because it's a long lesson. So this one says, write linear equation in point slope form. So this is our key concept. This is, all the new stuff from this year or from this part. So, sorry, I was trying to erase. So our point slope form is a new type of form to write the equation of a line. The two things that you're going to need when writing point slope form are, you guessed it, a point and then your slope. And that is going to end up in the equation y minus y sub 1 equals m times x minus x sub 1. So that is really what you need to memorize as far as this goes and making sure that you know what that form is. So writing linear equations in point slope form and using those to graph. So we're going to start off with graphing. And I know that this says to use your foldable, but if you're my student, Mrs. Taylor's student, you're not doing the foldable. But if you're with Miss Majors or Mr. Sissel, you might be. So definitely refer to them. So for steps to graph, the first thing is to graph the point x1, y1. So this is just a normal coordinate point, and we can get that from our equation. So our equation, which they told us in the last practice, was y minus y sub 1 equals m times x minus x. So the first thing we need to do is we need to identify this point that they're talking about. So we need to identify x1, y1. And if we look at our equation, we can see here we have x1, okay? But I want you to notice something about the sign difference. So in our equation, it's minus, and in our equation that is given to us, it is plus. That means, guys, that this one is a negative because here in our formula, it is subtracting. So the only way for this to turn addition is if that one is also negative. I hope that that makes sense. So x is negative 1. And then our y sub 1, if we look right above y sub 1, that is 3. And then our slope here is our negative 2. So those are the two things that we can get from this equation. So the steps to graph, it says first graph the point. So I'm going to graph our point negative 1, 3. That means I go left 1, up 3. Okay, and I'll label that negative 1, 3 so I don't forget. And then I'm going to use my slope to find the rest of the points. Slope of negative 2, excuse me, negative 2, we can put over 1. So that means that we go down to right 1. So from our point, we're going to go down to right 1. There's another point. We could even do it again and get a third point down to right 1. And then from there, we would be able to draw a line as best as possible through. So there is our graph. How to recognize point slope form. This is very important that you're able to recognize which is point slope form, which is y-intercept form, and be able to use those accordingly. So in point slope form, x and y are on opposite sides of the equal sign, which happens also in our y equals mx plus b. But the difference is that x is in parentheses and y is not by itself. So y doesn't end up being by itself. We have y minus y sub 1. So y isn't all by itself. Equals m times x minus x sub 1. We normally don't see parentheses in our point or in y equals mx plus b equation. So that's what makes this different. As we already know, m is the slope, and then this x sub 1, y sub 1 is the point that we can use to start with. So with our y equals mx plus b, we start with y-intercept. With this one, we start with a point. This is a good note about the sign differences that we talked about in that last problem. All right, write an equation in point slope form. So we want to take our information and write an equation in point slope form, which is y minus y1, y sub 1 equals m times x minus x sub 1. So they give us a point and they give us a slope, hence we point slope form. So these are all good pieces of information. So we know from this we have our point of 4, negative 3, and a slope of 2. So we can go ahead and build our equation from that. For my point, I'm going to label it x1, y sub 1, okay? So whenever we start doing our equation, I'm going to have y minus my y sub 1, which is negative 3, equals m, so that's 2, so m, times x minus x sub 1, which we identified as 4. So that is what I need to do. I want you to see what's going on over here with this y minus negative 3. We can turn that into a positive. And there is my best answer. Okay. So do you guys see how it ends up being a negative and a point if this is a positive in front of the number? So that's a little bit weird, but that's just knowing your formula and remembering that the signs are different. All right, so being able to graph, we kind of already went over this. So we need to, number one, identify your point and the slope. And then we would graph the point. And then graph using slope. So looking at our equation up here, use a different color. So in our original formula, y minus y1 equals m times x minus x1. So we need to identify a point as well as our slope. So our point is going to be our x1. So look here, x1 we have 3. And then our y1, at y1 we have plus 2, which means that this is a negative 2. And then our slope is 2/3. Using that information, I want you to try to graph this. All right, graph with mine. I started by plotting my point over 3 down 2, and then using my slope 2/3, which means I go up 2, right 3, and found a couple points and drew my line. All right, so using point slope form to write an equation. So now again, I'm going to write down my equation. Okay, so I know I need to figure out a point, and I need to figure out my slope. So if we look at our graph, there's a couple different ways we could find slope. We could use our points, and we could do rise over run, or we could do that y2 minus y1 over x. You could do either of these. I think rise over run is really easy once you have a graph. So to get from this point to this point, rise, I'm actually going to go down 2. I'm going to go right 2. So my rise over run ends up being down to right 2, which ends up being negative 1. So my m ends up being negative 1, so I can go ahead and start filling in. So right under m, I'm going to put my negative 1. And guys, it does not matter which point you use from here. You can use any point on this graph. It doesn't even have to be listed here. I'm going to go ahead and use 1, 1 to fill in. So I have y minus y1 equals, or my m, which is now negative 1, times x minus x sub 1. And I am going to use 1, 1 on my graph. So right here, I'm going to use this 1, 1 point to create the equation. Now, like I said, this is going to have varying answers because you could have used -1, 3, or you could have used 0, 2, or any of the points on the line. So this is my x and my y. So y minus my y sub 1, which is 1, equals -1 times x minus my x sub 1, which is 1. Notice how even though I had 2 points, I didn't like put points in for this y and x. Those stay y and x always. The y sub 1 and the x sub 1 are the only things that change. There's the equation. Right, write an equation in point slope form for the line that passes through the points. This is very similar to the one above, guys. We can use this y2 minus y sub 1 over x2 minus x sub 1, okay, to find slope. Okay, we would label these x1, y1, x sub 2, y sub 2. Okay, and then we would just use one of these points to plug it in to our equation. So I'm going to give you guys a second to try that and to try to find your equation. And then I'll show you my work. So here, right here is my work that I found my slope, and I ended up finding my slope as -4/5. And now to build my actual equation, I just need to use one of these points. I'm going to go ahead and use this -4, 1. So that is going to be my x1 and my y1. Right, so my OneNote crashed, so this might be a little bit weird, but I was just saying that I found my slope, and then I need to use my equation. So I'm going to choose either point. I'm going to choose this -4, 1, and this is going to end up being my x1 and my y1. So from here, I can build my equation. So I have y minus y1, which is 1, equals m. So that's -4/5 times x minus my x1, which is -4. Notice here that that's going to turn to a plus. So I have y minus 1 equals -4/5 times x plus 4. Now, like I said, you could have used this 6, -7. And if you did that, your answer would have been, so I'm going to use or, y minus -7 equals -4/5 times x minus 6. So I just, this is x1 now. So I get y plus 7 equals -4/5 6. So if you did it with the other point, then that is perfectly fine as well. All right, a multi-step problem. So you are designing a ticket or a sticker to advertise in your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Sorry, for each additional 1,000 stickers. Write an equation that gives the total cost in dollars for the number in thousands of stickers ordered. Find the cost of 9,000 stickers. I am going to pause here and allow you to try this. This is what I know so far. I know that x is going to be my number of stickers, and that's because it tells me as a function of the number of stickers, and that means that f of x thing. So that x is going to be the stickers. So this in thousands thing, guys, is what is so important. So I am going to use it's $225 for the first 1,000 stickers. So that is a point, guys. It is $225 for 1,000 of the stickers, okay? And actually that's going to have to flip because cost is y, I'm sorry. So for 1,000, so that's just one because our number of stickers is in thousands, is $225. So that is a point. And we know that it is going to be $80 per 1,000 tickets after that. So $80, guys, is our slope. That is our constant change. Okay. Using this, we could write an equation. So y minus my y1, which is 225, equals our slope, which is 80, minus my x sub 1, which is 1. Okay. Using this, I could figure out how much it is going to be for 9,000 stickers. So stickers is our x value, so we could plug that in for x. I'm going to stop here and try that. At my work, I got $865. So pause and look at this and definitely ask a question if it is confusing.